Yeah, so I think we can start now. Uh, Welcome everyone to this live session of 2-week refresher course in computer science on next generation technologies is sponsored by Ministry of Education. We have our keynote speaker, Arpit Joshipura. Arpit is General Manager, Networking and Edge at Linux Foundation. Arpit is an executive leader and open source software evangelist across carriers, cloud, and enterprise IT, spanning networking, orchestration, operating systems, security, AI, edge, hardware, and silicon. He was recently voted among the top 5 movers and shakers in the telecom industry. At the Linux Foundation, Arpit leads open source networking, orchestration, and edge IoT, including LF networking projects, ONAP, Anuket, ODL, FIDO, OVS, DPDK, Open vSwitch, Acrino, Edge, IoT, etc., as well as major industry disruptions, including VNFs to CNFs, 5G, AI, etc. Arpit brings 30 years of networking experience, expertise, and vision to the Linux Foundation with both technical depth and business breadth. He has orchestrated and led major industry disruptions across enterprises, carriers, and cloud architectures, including IP, broadband, optical, mobile routing, switching, layer 4 to 7, cloud disaggregation, SDN, NFV, and open networking, and has been an early evangelist for open source. Arpit has served in CMO, VP, and engineering roles within both startups and larger enterprises. So, Arpit, welcome to you, and good evening to you as well. You're joining from
yeah
yeah, over to you.
Okay, good morning everybody, and thank you for having me. And I'm excited to join virtually, and I believe we will have plenty of times for question and answers. So feel free to throw the question in the chat while I speak. What I'm going to do, and I'm going to share the slides right here. Can you see it?
Yeah, we can see it. Yeah.
Okay, perfect. So I was asked to cover networking and edge, and then my colleague after me would be Tina, who will cover details of edge blueprints and examples of use cases. But again, networking is very wide and very vast, and then open source is even wider. So I think what we have to do is break it down and kind of walk you through a few of these disruptions that have just happened. Now, let me start off by saying that I think you've heard from my colleagues, Brian and Priyanka and others on Linux Foundation. So I'll go very quickly onto that. Talk about the open source journey in networking, and then talk about how things have gone into production deployments. And then we'll talk about some of the open source projects coming together. Okay. If you think open source, the next name that should come to mind is the Linux Foundation. That's synonymous, right? And our goal is very simple. We share the greatest technology investment and build it for the open world, right? So that everybody can collaborate. And we are a nonprofit. I think you have heard about that. What's more interesting is we host these projects, and there's a lot of projects, right? There's almost 800, 900 projects that we host. Just because you can throw code on GitHub doesn't mean that we will host it. That's not, I mean, there are millions of projects on GitHub. We are only interested in hosting projects that need a community behind it, that disrupt, the markets, they disrupt technology. And they are the most important projects that are there in the world. And so there's about 600-700, and I'll talk about that in a bit. So we host projects. Projects become products. Once open source software is created, they are taken into deployments. They move into money-making business, everybody, and then it gets invested back, and everything is good to go. So that's the cycle for Linux Foundation. But at the heart are projects. you might have seen this slide from my colleagues, but we're much more than Linux. Linux is pretty much everywhere in the world. But we have, in the last 20 years, expanded between, security, networking, which we'll talk about today, cloud, you've heard about that already, automotive, blockchain, edge IoT, I'll cover that today, web, AI, film, et cetera, et cetera. So a whole bunch of projects in multiple areas. Now, these areas could be either technology disruption or market disruption, okay? The thing that we need to understand is, we are nonprofit, but we have membership. So members basically run the foundations, and they influence the roadmaps. And most of the universities, governments, etc., are nonprofit, so are associate members, obviously no charge. But as these members influence and as they contribute through developers, you can see the type of changes that happen. 31 million lines of code added weekly, right? 20 million lines removed. 1.1 million pull requests, right? 10K repositories scanned, right? It's just the scale of operations at a global level is way more than any individual company or country combined. And that's why the power of open source is making LF a critical part of modern technology. Okay, so I know this whole session is intended at understanding how open source can be utilized and enabled, but it is important to know why open source has become such a phenomenon. And if you need to know the major industries, I would suggest downloading this white paper from the Linux Foundation site. It's fairly recent, and we published this white paper to what I call open sourceification. 100-plus-year-old industries, telecom, automotive, motion pictures, banks, public health, energy, they all were completely proprietary for the last 100-plus years. And in just the last 5 to 7 years, they have gone through a radical transformation of becoming completely open source enabled. So please download this white paper. It's really good reading. All right, so with that background, I'm going to jump into networking, telecom, enterprise networking, cloud networking, and then obviously cover the edge as well. And for those of you who are in this space, you're quite familiar with this, but for those of you who are not, I want to emphasize the following, which is 20 years ago, servers went through this virtualization technology, right? Where every workload or every application did not have to reside on a separate server. You could virtualize it, and there came VMware. That same concept came into the network through something called NFV. And early days of OPNFV was the project where you started working on the virtualized pieces of networking software. Then came disaggregation, where you can actually buy hardware and software from separate vendors. And the power of that was hardware became commodity and cheap, and software was software defined, right? So the control plane, data plane separation, as we always called it, huge revolution. That was the start of Open Daylight and some of the early networking projects. Since then, the layers of software moved up the stack into automation. We're at the cloud native era right now, where Kubernetes is the underlying infrastructure layer. And as we move forward in the next 5 years, most of the networking will be edge and intent-based, enabled by AI and open collaboration. And the boundaries between an enterprise network, a carrier network, or a public cloud network will diminish. As you saw from last week's Mobile World Congress announcements, AT&T and Microsoft partnering, Google and Microsoft partnering, et cetera, et cetera. So this is kind of the journey, and this is where telecom networking is heading. Now, the main problem that exists today, projects are well understood. People create code. Code has gone into production. no issues. Uh, one of the main problems that exist is how do I integrate many open source projects, and which ones do I integrate? And when I integrate, do I integrate in an open community so that I can have open compliance, open verification, open interop, open testing? And when I have that, it becomes repeatable. So we have two initiatives going on in the Linux Foundation. One under Linux Foundation Networking, which is called 5G Super Blueprints. It's a very exciting initiative. And the other one is under LF Edge, called Acrano, which has a set of blueprints. And Tina will cover that, but I'll give you a high-level view of those. But the goal of those is to accelerate the projects and products into production. We've done some early analysis, and it looks like we shave off about 6 to 9 months of interop testing. So take, for example, when 4G was deployed, a Geo or a Bharti or Airtel would go in and say, okay, I'm going to deploy a base station and a core from Cisco or Juniper or Ericsson or Nokia, whatever. And then they would spend 3 months testing those products together. And then there would be bugs, and then those bugs would have to be rectified. And then eventually they would end up fixing them, and then they would put it under POC, and then finally under production. That whole cycle had been anywhere from 9 to 18 months. What this does is they all are built on the same frameworks and same open source code, so they are by default interoperable. And then on top of that, the blueprints test the APIs and everything. So it's very, very rapid innovation. All right. So once you have this concept at the bottom of this chart, which is super blueprints, you take all these projects that are relevant, and I'll show you all of those and where they fit in. The three markets that are really excited about it are the enterprise networking market, the service providers, and then the end users, including government. And the use cases for each of those are written here. You don't want to solve every use case, but the most relevant and important use case, like private networks, 5G or LTE, or like moving workloads across multi-clouds, like getting end-to-end visibility and monitoring, right? So if a Walmart or is connected to an AT&T, is connected to a Google, and this is a real scenario in the US here today, how do I get my workload visibility between, and how do I monitor between these three different hubs, right? That's kind of what the enterprise networking problem is. The service provider network problem is fairly straightforward. I need to deploy 5G end-to-end, and I need to get global connectivity up, multiple countries, cross-cloud VPNs all over. And then the end users, like enterprise and governments, they want to utilize this for 5G. They want to unify this experience. And we have the US government, or the DARPA, DoD, very active in our projects, LF Networking and others, LF Edge, that require these blueprints to come together, right? Because all of the US is being enabled through the Innovation Act and through the new administration on 5G and IoT. And then we have seen governments in Africa, some in China as well, taking advantage of these blueprints. So that's kind of the plumbing layer, if you may. And then on top, the vertical markets are and this is in a linear order. So this is for the edge compute and IoT. So industrial manufacturing, most relevant to edge computing, then energy, commerce, home, automotive, fleet. This is how the participation is going on, and this is how the markets are adopting to edge computing. Doesn't mean healthcare and smart cities is not important, but there's a lot of government regulations and processes that need to go through. Okay. All right, so we take a deeper step here and look at how these projects enable these use cases, right? So it's a fairly straightforward diagram, left to right. You have the enterprise and the user, mobile, residential, small, medium business, or large enterprise. You come in through what is called a user edge, and I'll get into the definition of edge in just a moment, either through a project called ORAN. This is the ORAN Alliance, Open RAN software. So I host the ORAN software at the Linux Foundation as well. And then you have either Home Edge, that's a Samsung contribution, which is part of LF-Edge, or Fledge, which is a very industrial IoT project. And we'll get to the use cases in a bit, but let's say the user edge comes into a service provider edge, which is where a Crano and a set of blueprints fit in. And then through the clouds, many of those, you get into the core of the network, which has a stack from infrastructure. You heard about Kubernetes, any data plane acceleration kits into control plane, the Open Daylight Tungsten Fabric, and then you get into management, self-driving networks, zero-touch networks. There's many, many names enabled by a project called ONAP, which is the largest of all. And then you get into the applications, VNFs, CNFs, and in this instance, you could probably say, hey, a mobile packet core is an application. And so we have a project called Magma that was recently moved into Linux Foundation by Facebook. And that is one of an important project for the blueprint as well. So you can see the end-to-end view of what these projects, where they fit in and how they can pull in the entire stack. Okay, so let's double click on Edge in a bit. The one thing I want everybody to remember is the definition of edge. And historically, everybody has kind of used terminology that is wrong. Okay, thin edge, thick edge, far edge, near edge, this edge, that edge. They're all relative terminologies, right? It depends on who you are and where you are from that perspective. So what we did at LF-Edge and Linux Foundation Edge is a great umbrella to participate, is we published, every year we published a Wikipedia style project called State of the Edge. And there is a research report you should download, which is a white paper on LF-Edge website as well, where the terminology has been standardized by the community, right? There was no analyst who was doing this terminology. So we just decided that let's just do it like a Wikipedia style. So let me explain the terminology and it will be very simple. So when someone says edge, right, there's only two types of edges. There is at the bottom, there's a user edge, which is dedicated and operated. And then there's a service provider edge, which is shared and as a service. And typically the last mile separates it, but it's not a hard cut all the time. So the colors are blended. Now, the user edge itself has multiple incarnations. You can have a constrained device edge. So these could be microcontroller or embedded compute. They could be smart device edge. So these are IoT gateways on a server, semi-secure locations. Or you could have an on-prem data center edge, where you can actually have a couple of servers, multiple of these inside, but still everything in the control of a user dedicated to your enterprise. Okay, that's kind of the user edge. If you cross the last mile, on the right hand side you have access edge, and there are two implementations of that. There's an access edge under a base station, and this could be up to 6 servers, 2 to 6 servers, right, depending on the size, and then move up a notch into a smart central office or what's called aggregation hub. That's where the edge stops. After that, it's a regional data center, and then a centralized data center, right, like a Google or an Amazon or an Azure. So the thing that you have to understand is not all IoT is edge, but some of the IoT is edge compute. So typically applications that need less than 20 milliseconds of latency or need 20 milliseconds of latency is an edge application. So if a sensor that dumps data every week to an Amazon cloud, that's an IoT application. It's not an edge application. Okay, so keep that in mind. 20 milliseconds plus mobility plus bringing storage and compute close to your application. That's kind of what edge computing is. On the top of this chart, you see a number of projects that we host. There's about 10 projects, everything from infrastructure to applications. The two key ones are EdgeX Foundry and Acrano. And I won't go into all the details. You can look it up, but I'll talk about the use cases for each of these. The thing that's more interesting is what Acrano does. And Acrano has a whole set of blueprints. And after me, Tina will cover each of these blueprints in detail. So I won't go into all of it, but really excited about some of these, like cloud gaming, for example, or connected vehicle, or private 5G, or the most recent one, public cloud edge interface, right? What blueprints are they are declarative configurations where people can actually replicate this in the open and utilize this and deploy it, right? It's a set of hardware, software, CI/CD, the whole thing. And this has gotten very, very popular, okay? But these are edge and IoT blueprints that Acrano, there's about 20 plus and more are coming on the way. And the dots just represent where these blueprints have been tested for. All right, so then if I go and look at the use cases that are enabled by each of these projects, ORAN is all about 5G. It's all about end-to-end network slicing. It's about white boxes and disaggregation. So if you're familiar with the ORAN architecture, ORAN Alliance architecture, the CU, the DU, the non-real-time RIC, the SMO, all of these terms that eventually allow for open source to go all the way into the RAN. If you look at Kubernetes, that's your infrastructure multi-cloud layer. If you look at Anuket, that's an excellent project because what it's doing in LF networking is it combines what used to be OPNFV and a telco initiative called CNTT, and it made it into Anuket. Anuket basically provides reference implementation for an OpenStack-based deployment and for a Kubernetes-based deployment, right? So it kind of has the entire implementation, and GSMA is our partner that defines these specs, and the implementation happens in open source. And then ONAP on top is all about 5G, network slicing, cross-cloud VPN, zero touch, closed loop automation, et cetera, et cetera. And then I talked about Magma, which was the wireless. If you look at the use cases on edge, everything from anomaly detection to DevOps at scale and on-prem to predictive maintenance for constrained devices, IIoT, right? Turbines, transformers, pumps, TensorFlows, et cetera. And then building automation, industrial process control, water, retail, et cetera. Lots of huge cases, right, that have been already deployed in the marketplace. All right, so that's kind of the first step, I would say, from a project perspective. I'm going to pause and see if there were any questions. Feel free to put questions in the chat. Definitely going to answer all, if not as many, just so that, I know this is an education session, so feel free to put questions as they come along, or save it to the end as well. So the next section is about, so great, you have all these projects. Which ones do I use, in what order, and how do I get to a use case? And so LF networking, which is kind of one of the largest umbrella foundation projects under Linux Foundation, from a size perspective. Obviously, CNCF, which hosts Kubernetes, is the largest. LF networking is the second largest. We are hosting what is called a Super 5G blueprint. And what it does is it takes multiple of these foundations, and whether it's networking, edge, Magma, CNCF, ORAN, and then it provides a step-by-step open interoperability and integration into these projects, right? There's a mailing list, calendar, et cetera, et cetera. So feel free to, look, just if you search LF networking 5G super blueprint, it'll take you there. Do join the mailing list, do join the meetings, because this is kind of one of the best examples of pulling these open source projects together. This particular view is provided by our friends at the US government, DARPA, through the LF networking initiative. And it's very interesting because what they're saying is, I'm going to utilize 5G for everything from public safety to defense to enterprise to my own connectivity. And I'm going to utilize these projects because we fundamentally believe that open source is more secure, because you can't put anything in there, right? So from a security perspective, I'm not going to go through all the security scans and the CVEs and the whole process of security that Linux Foundation has. But in general, open source is more secure and it's faster to innovate. And so they are going to utilize the entire end-to-end stack based on open source. And these are some of the projects. Now, I don't host all the projects, some of them are outside my scope, but we are going to pull it in to a full end-to-end stack that can be utilized for various use cases. So what are how does it come together and what are we seeing here? So if you look at the phases, phase one is essentially, Kubernetes, ONAP, Anuket, Magma, coming together for fixed wireless, private 5G, multi-access, etc. Then you add network slicing, and then you add ORAN. I'll show this to you visually, and then you will kind of get a good understanding. So the first phase, Magma, again, remember, Magma is the open mobile packet core. You take Magma, you take ONAP, and you take Anuket, Kubernetes. Akraino already has a print called ICN that has integrated Magma with it. And then basically core, edge, and then bottom is the NFVI layer, which is proven already. There's plenty of implementations of NFVI. So you take this and you use emulators on the RAN side, right? The next phase, you start doing commercial G node Bs, right? We are still at the mercy of the top 3 to 4 players on the commercial G node B side, right? The Ericssons and the Nokias and the Samsungs of the world, from a global perspective, and obviously Huawei and ZTE for China. And then in the phase 3, you add ORAN SC, or the software community, to it. Now, the good news is ONAP has already proven over Naven interfaces, right? So all the interfaces have already been tested in the current release of ONAP. So effectively what now happens is everything comes together. Now you can have these use cases. You can repeat this, and then vendors and system integrators can build on top. Universities can test on this, right? And this is all done as part of the open community. Okay, so from my perspective, our priority is that from an open source networking and edges to complete these stacks, speed up the backend interop process, and integrate this into vertical markets, right? Because everybody wants to utilize the power of networking, power of 5G, power of edge. Okay, so that's kind of the high level view. Now, what I'm going to very, very quickly flip through is some more background on the overall landscape. Since this is an educational session, I don't want to just limit it to Linux Foundation, right? So if you are interested in networking, telecom, as well as edge, there are multiple foundations that are focused on this, right? So there's the Linux Foundation that we talked about, obviously largest and the largest community. There's the Open Infrastructure Foundation, which hosts OpenStack. I think Jonathan's going to talk to you tomorrow. There's ONF, there's Eclipse Foundation, Apache, which is mostly around big data. And then there's a few others. In terms of standards, you have GSMA, ETSI, 3GPP, ORAN Alliance, TM Forum, MEF, NGM, and ITF, TIP, and OCP. Now, we at the Linux Foundation, specifically networking and edge, my philosophy is if a standard exists, code it. If it does not exist, code it and then upstream it to the standard. So we have, for the past 4 years, established a very deep relationship with all of our standards organization, so that when you get to deployment, you don't have a mismatch of a standard and an open source, because there's a very high possibility that open source becomes a de facto standard. And then you don't want ETSI to catch up 5 years later, and then you don't have it drop, right? And then there's alliances, specifically on the edge side, right? Automotive edge computing or IIC, and we just signed a partnership with Digital Twin Consortium, etc. Okay. All right. So those are the stack. Now I'm showing things that I host. We partner with the rest of them that are not hosted, and then some examples, right? So with Etsy and ONAP as a network automation software, these specifications are actually implemented in the code, right? Same thing with GSMA and Anuket, or TM Forum specs, or MEF, all the northbound, or 3GPP, right? These are all specifications that have been written and implemented in open source. So that cycle is really, really fast. Okay. And then, of course, we work very closely with open source foundations within LF and outside to make the end-to-end stacks. And I'll particularly call out three here. One is CNCF. So in CNCF, there is Kubernetes, plus there is a set of networking technologies, including telecom user group, that we make sure that we pull in and integrate. We have LFAI, which is hosting Acumos. So Acumos is AI and data right now. The Acumos is a project which has sort of templates for telecom. We partner very closely with Hyperledger. So this is blockchain for telecom. There are 3 use cases that are used, that are implemented. We had announced it as part of Mobile World Congress a year or 2 ago with Hyperledger. And then, of course, OpenStack and some of the others. Okay. I'm going to send these slides out and you can have this, but each of these projects has the name, the link, the wiki, etc., the chairs. I won't go through all of them. FDIO is the data acceleration. So it's used by a set, it's sitting on top to make really fast path go. This project's inside called VPP for the technically minded. ONAP, as I said, the largest of all. This, again, just a little bit of history. This is now deployed at, and I'll talk about where it's deployed, but it started off with AT&T, and now it's kind of the global de facto standard. Okay. Open Daylight, one of the first earliest project on an SDN controller. Tungsten Fabric, another one of these controllers from Juniper. The difference is this is an overlay controller. And then we just incubated a project called XG Villa, which is platform as a service. So that separates that one out. And then I'm just going to walk you through some of the examples of ONAP, right? Because, and this is getting way into details, but this 30 sub projects inside, right? The goal of ONAP is very simple. How do you get network automation in the world of 5G and IoT when you cannot have manual changes? The network has to run itself. It has to be zero touch. Anything happens in the network, there should be a control loop that allows changes to happen. That's what ONAP gives you, okay? And ONAP has obviously become cloud native now completely with cloud native network functions being there. But let me walk you through some real world examples. AT&T, for the last 3 years, this has been in production, and it's been production including first net responders. So all the firefighters and cops and everybody, right? Like as they move into territory which needs network connectivity changes, they used network automation based on ONAP, right? So very active. The chair of ONAP is from AT&T. China Mobile, fully implemented in one of their largest provinces deployment. Orange, last week, they publicly announced that ONAP is now in production. Huge journey by them. China Telecom production. Verizon, they're going to go into production later this year. Bell has been in production since Bell Canada in 2019. Deutsche Telekom, just at Mobile World Congress, announced that they have gone into production as well through their trial. Geo was an early contributor and a big supporter of ONAP. I think what they have done now is they've taken the basis of ONAP and then built on top for the deployment in India, right? Very powerful. All right. so I'm going to skip some of these slides. You can look at them. So at the end, where do I start, right? You start through foundations, you start through projects, you start, going through training. So I would definitely encourage you to go to Linux Foundation training and sign up for as many courses as you like. There are lots of free courses available, including fundamentals of open source, DevOps process. There's a course if you're a network admin, how do you move from network admin to DevOps admin? Okay, so there's a lot of these, participate in blueprints. And all you have to do is get yourself a Linux Foundation identity and get into either LF Edge or LF networking wikis. And then you join sessions, you give talks, you submit code, it's fairly straightforward, right? Now, if you are a vendor or a service provider, we would love to have you join these organizations and foundations so that you can contribute and influence, but you don't have to join, right? Like to contribute. And then these are just some research reports and white papers you can download. Okay, that's pretty much the formal presentation, and I'm going to open it up for questions. We have about 20 minutes of questions, and I see a few of them.
Thanks, Arpit, for such a brief introduction of a lot of things. And I want to thank Linux Foundation Networking and Edge, because sometimes you always feel that there is a standard bodies, there's a open source code, means where to see. Like, for example, if you have RFCs, IETF means ITSI, and then when you see code, that's a very different page. And now this is what you guys are busy filling this gap of academia and industry and open source. That's really cool. And I also want to thank, because interdisciplinary is really important. Like you said that Hyperledger, now blockchain is also part of that. And I remember we wrote one white paper with LF Edge and LFN. This is on Hyperledger. That's really interesting how you guys are willing to collaborate with other projects as well. So yeah, with this, I have some questions for you. Like this is from Parth, that what blueprint should academic campuses start looking with for a small hybrid cloud use cases? So this is, I also want to add, like sometimes, in academia, if you have some blueprints where they can, if you have more automation, like, because the focus here is more on, optimization, research problems, not in implementation part. So if we can have something for like academic stuff, like as a blueprint, or if you want to recommend something that this blueprint is really helpful for academic people to install something or to use something.
Sure. So I think the answer to that will obviously depend on how wide you want to go, right? Most of the US research institutions, and they are all part of the US government funded project, DARPA projects, right? They are going to utilize the entire 5G super blueprint end to end, as I said, right? RAN to edge to access to core, all the way up to the Magma layer, right? So Magma, ONAP, Anuket, Akrano, ORAN, etc. They're going to utilize that. So there's the underlying plumbing layer, and then they will build on top. They will build NLP. They'll build security. They'll build algorithms that kind of encrypt things, and very fancy, sophisticated PhD type work, right? But underlying is a real stack, right? That is glued together from an open source perspective. And then what they'll do is they'll submit those changes back into the upstream community, right? So if, for example, the use case is network slicing, right? And ONAP supports network slicing, Magma will support network slicing, and then RAN network slicing. And now you have an end-to-end slice. And USC, for example, here in LA, is doing research on secure network slicing, right? So now how do I encrypt that? Now, that research has to run on a real slice. You can't just have simulators for that. So they're going to utilize that, test it on the blueprint, and then they will submit that back into the upstream code so that ONAP in general becomes much more secure when they do slice for all the world, right? That's how the process works. So the reason I gave you this example is depending on your use case, right? You can start participating in the community, and then you can, you will find very quickly by asking or whatever that this is a good set of projects that I need to pull in, right? If you don't need a real RAN, you can just do emulators. If you don't need, or don't need a full 5G open core, you can buy it from someone, right? Like you may have an emulator there, right? If you're testing just the edge, just do a Crano, right? And just do blueprints there. So I think it depends. It's just, this is where I think we typically, once you join and participate in communities, you realize what is there and what you can use and all that.
Yeah. Thanks. Arpit, and another question is from Prakash. Anuket, Kubernetes, can you talk more about it? Or Prakash,
yeah. No, I think I understand the question. See if I can, I'll answer it.
Sure.
So Anuket, if you remember, as I said, is a project under LF networking that combined two projects, OPNFV and what was called CNTT. It was a task force work hosted by GSMA. So what they have done is they have defined something called RI1 and RI2. RA1, RA2, right? So reference architecture 1, reference architecture 2. Reference architecture 1 is based on OpenStack, and reference architecture 2 is based on Kubernetes. And then for that reference architecture, what Anuket is doing is it's implementing the RI2, which is implementation of that reference architecture. And so that's what the blueprint is going to integrate, right? Which is how does a Kubernetes software, what loads, what modules, what APIs, things like that, defined by the RA2 spec from GSMA. How do you code it, implement it, and test it? That's what Anuket Kubernetes is. Prakash, does that answer your question?
Yeah, it does. So are we thinking that RA1, RA2 are independent, RI1, RI2 are independent? There is no way that somebody will want both?
No. So
and together,
by default, all the carriers are going hybrid. Okay. There is not a single carrier who is just going to be cloud native. People may market that, let's face it, but the first implementation is always going to be hybrid. So there'll be VNFs and CNFs, and there'll be OpenStack in majority of the instances, but moving away from OpenStack into Kubernetes. So the new deployments will be Kubernetes on bare metal, right? So the reason they've separated the two architectures is some people only want to test and build OpenStack based for now, and then new deployments, right, in new POPs might be Kubernetes only based. So you want to keep the two separate, but the testing is a hybrid, both.
And the hybrid means in terms of VNF, CNFs only, or in the cloud perspective as well?
Both, because multi-cloud, intercloud is available in most of the OpenStack, most of the ONAP modules as well, right? So when you have automation like that, Kubernetes also has a layer. Now, keep in mind, the difference on multi-cloud and intercloud, it varies because Google has their version of Anthos, right? Azure does their thing. Amazon does their thing, right? IBM and others will do their thing. So public cloud players themselves will allow you to interoperate, but they're not all the same way. So just keep that in mind. But it's all multi-cloud, yes.
So that is the actual thinking is that going forward, if container is going to be the primary as we migrate, and even we are thinking, like example, I think Parth was looking at cloud native OpenStack. Okay, there is something called KubeOpenStack. They are looking at it. So we were thinking that can we contribute to part 2, which is the RI2, We have RI1, RI2, maybe we have something RI1 plus 2 kind
I
of thing.
think, yeah, so you should definitely take a look at it and look at what the telcos are doing there. And I think there are definitely there are challenges on the hybrid layer. And here are the challenges, right? Because at the end of the day, you don't want to go, bare metal on OpenStack or bare metal on Kubernetes on OpenStack with Kata containers and this and that. Like there's too many layers and too many flavors, right? And I didn't have that architecture diagram here. I can show it if you want, but in a CNF world, you need, and there's ways around, you can use OpenStack with that option, or you can just do KubeVirt or Kubelet or things that are much more lightweight, right? Because in a container world, you don't. The good news is the networking constructs are not embedded in the cloud layer, right? That's the fundamental difference. It's not OpenStack versus Kubernetes. But what OpenStack did was it had Neutron and concepts like that embedded inside. And Kubernetes kept the two layers separate, right? So that's why it allows a more lightweight container-based approach. So there's fundamentally inherently architecture differences, right?
Yeah, and yeah, I want to I get confused with the multi-cloud, because you said hybrid cloud, multi-cloud, and inter-cloud. So if you can differentiate it a little bit. So
yeah.
Inter-cloud is the new one for me. So
okay, so inter-cloud. Let's start. That's the easiest to understand. So there is between clouds, like there could. So let's take Vodafone, right, or any of these large carriers. They all have deployments in different countries. Okay, each of these countries could have their own data center, but it's still their own, right? So that's kind of what I would start off with, what is called cross-cloud VPN, right? It's their own cloud, but across countries, right? Which allow for a homogeneous view and a homogeneous automation and orchestration, right? Now, in that same context, a hybrid cloud or allows deployments on-prem into an enterprise, right? So for example, I'm a automobile manufacturer and I have a company, I have a factory in India and in US, right? And I'm serviced by a Vodafone or a Deutsche Telekom or whatever, right? That is global or has relationship with global carriers, right? That needs to work also, the automation, the orchestration, the logs, the events, and all that, right? So those are the two easy to understand. Then you get into cloud, where you have between an edge and a core, right? You have APIs. And that's where the blueprints that Akraino came out with, a public cloud edge interface API, right? So because there's no standard there. Okay, it's just the code that's going to be the standard, right? So that's kind of that. And then I think multi-cloud is just a generic term to make sure that if it's Amazon and Azure or this or that, right? Like you operate, right? That's kind of just a basic term. All right. Other questions?
So we have one more. Akraino ICN blueprint has Magma. So I think the question is.
No, that is true. Akraino ICN. So there's an ICN blueprint, and Tina will cover it right next. It has Magma integrated with in an open source already. So that blueprint is already available. Okay.
And I have one more question, and this is regarding sometimes, Arpit, it's really hard for academicians or governments to look into these projects in terms of wideness. It is like from you have like 10 or 20 projects, like which suits me better or not, or which is good for me. If you can refer some sources which can be like a exit where we can look, is it a wiki we can look at into, or or
all
you
of
recommend
these,
something?
yeah. So I would say there are, LF. I think it was in my slide, but lfnetworking.org. Sorry, LF Networking and LF Edge have their own wikis, right? And the best source to just get an overview is there will always be documentation and white paper that that define every project, and they say how much and all that, right? Now, if you're looking for community momentum, each of these projects have something called LF Insights. So that's a tool that shows the developer velocity and which companies are contributing. It's called LFX Insights, right? So you just go there and search for ONAP, for example, and you will see who is kind of contributing, participating, which companies, including the engineers there, right? So those two are your sources, right? The wikis and the, of course, there's a website, right, for the simpler version of it. But then you want to get into the source code and source documentation, it's all the wikis.
Thanks for info. I think
Yeah.
we will take some questions from discussion forum as well. We have this. We will upload this on our OpenEdX platform as well. And if we have some more questions, we can bring you directly as well.
Yes, absolutely.
Thanks. Yeah, Prakash,
So
do you have...
Prakash here, just to, yeah, I have one question. See, let's look from the point of view of Indian education system, healthcare system, and government. And suppose we want to have a campus-wide network. When I say campus-wide, means all the researchers in all the campuses want to work together, and they can do cross tenancy in the sense that few of the researchers who are in, say, IIT Madras can deal with IIT Bombay, Delhi, or something like Delhi University, Ramanujan College. So now, because a project like example Shakti, let's say we are doing on RISC-V, we need to come with people from all over the places. So the question which Parth asked was blueprint, and that was blueprint for maybe for one campus. Now you have the one which you showed blueprint for the entire US. So can we similarly work with you to get an entire blueprint for India for specific to start with, let's say, campus network, and then maybe
Yes.
healthcare network?
Yes.
I think that will be a very good exercise for us to learn and bring something very valuable from everybody. Yeah.
Okay.
Go
So
ahead.
I'll just say the answer is yes, but do not assume that the blueprints are for a country, right? This is the difference, right? This is the geopolitical aspect of open source is completely eliminated in software, right? There is no such thing as a blueprint for India or you. Like I just gave an example of US government. They're using it, but China is contributing, Germany's like global developers are contributing, right? So effectively, and I think one of your next questions is exactly aiming at that, which is if I'm a downstream user called IIT or Government of India or healthcare or whatever, right? Like an end user community, how do I take advantage of upstream, which is the open source community, and influence that through neutral governance and neutral processes, right? So it doesn't have to be India, because what you don't want to do is you don't want to set up a VPN and a private repo of just the 5 IITs and ISC coming together with a few of the government, because now you're in the old way of doing things, right? It's a closed network. What you want to do is you want to go upstream, pick the project, influence the project, and then pull it down so that it is open. It's not forked. It is not closed, right? Because then you're fundamentally what you're doing then is you are bringing the global innovation versus just Indian innovation, right? You see the difference?
Yeah, I see the difference. That is why I asked you the earlier question: how do downstream users like CSPs, telco providers? If I am AT&T, I use the, let's say, Akraino as well as Airship and all that downstream. But what we put on called network cloud in the what they call as one of the catalogs, I really can't use that fully because a lot of things they do inside is never coming out. And
No, you
so
don't need to.
what do
You
I
should
do?
not. No, because what
How?
they do, no, what they do is they used to do that, right? Which is they used to have code in network cloud that was different from what was in ONAP or Airship, right? Now, in the last 2 years, AT&T has adopted this upstream first policy. So if they need to change a catalog or they need to change something that is in open source, and 90% of the code now is in open source, right? The only thing that's not in open source is AT&T specific catalog items, right? Their pricing, their keys, et cetera, et cetera. So now what they do is they put, if they want to change the code, they will change it in open source ONAP and then pull it down. They have a CI/CD every 2 weeks, right? That goes in and integrates. So there is no more fork. They get the benefit of the global community, and they only have to add the 10% of their AT&T specific things.
Yeah, the
So
devils are in the details. Devils are in the details, and the same thing used to happen with the China Mobile,
sorry,
China
disturb
Unicom,
you.
China Telecom, and yeah.
And
So
I think
yeah,
we're running out
We are
of time.
running
Right?
out of time. Yeah, we
Yeah.
can take these questions later. Yeah. Prakash, so on this behalf of the organizing team, Open Technology Foundation and Teaching Learning Center, Ramanujan College, University of Delhi, we extend our heartfelt thanks to you, Arpit, for taking out time and interacting with our participants.
Thank you.
We really hope to have more engagements with you in future. Thank you so much, Arpit.
Thank you. And I'm just as a closing, please join LF Networking, LF Edge, right? You can go into the wikis, sign up for the ID, right? Like you have to participate to take advantage. You can't just take advantage because you will never know otherwise.
Yeah. Thanks,
Right.
Arpit.
Thank
sure.
you. Okay, bye-bye.
Right.